back, everybody. We're going to be making this sprite sheet today, or looking at making a sprite sheet today, which will build out a background for an RPG. So if I just show you this running quickly, the idea is that we're able to use a tile sheet to actually build out like the background to a level like this, and then we can draw that tile sheet using a text file. So if I very quickly show you, in here I have a small sprite sheet. So this is where obviously each one of these squares have been taken from this sheet. I'm going to talk through how that works in more detail. And then this map here is a text file where each one of these numbers corresponds to an area on this sprite sheet. So if we look, 0 on my text file map I've made corresponds to this top left section, 8 corresponds to this top right section, 1 is this top section here, and so on and so on. So I can build any background that I want just by using a text file, and then I can get the computer program to run through that text file, chop up the sprite sheet and draw it like this. So it's just a nice, quick, easy way to kind of draw a level. And if you gave it some rules and things like that, you could procedurally generate a level like this every single time. So if you think about it, a level like this only needs, the rules are, if we wanted it to be an island, is that there has to be like this blue line around it. So these corners always have to be in these positions, and we have to have 4s down the left hand side, 3s down the bottom, 5s up the side here, and 1s at the top. Once those rules have been met, anything on the inside we could program to kind of be random. But we're not going to look at the procedurally generated and random side of it today. We're just going to get the stuff working, and then we can generate the other bits of it later on. So without further ado, let's get going. So first things first, we want to make a Python file for it. RPG demo or something like that, and you want to make sure you save it in the RPG folder that you've got there, because in that folder you are going to have your map file, and you're going to have one of these overworlds as well, and I'll talk to you more about some of the other bits and pieces. You don't need a lot of the other stuff right now, so it's just, that's all we need, the map file and the overworld small. I'll put a link in the description to where I got this overworld from. There's a Sprite website, but I'll make sure I credit the creator of that as well in the description. So first things first that we need to do is, just like normal, we're going to import Pygame. I'm going to start off by actually drawing, or like creating the tile map class. So class tile map is what we're going to have a look at, and it's going to be using a lot of the inbuilt sprite stuff that Pygame actually does. And then we're going to initialize it, and the arguments we're going to have for this tile map is that it's going to take a sprite sheet and it's going to take a map. Okay, so the reason we're doing that, we could just pass it in the name of the sprite sheet, so overworld small, and the name of the map here. But if we do it this way, it means that we can reuse this class and we can load in different levels and things like that. If we define what we're passing into it here as a constant, it means that we'll have to basically unpick this later on if we want to load a different level in, which we kind of don't want to do. So we're going to set it up now to be as robust as it can. We're going to just do super, and we're just going to do an inheritance here as well. So again, I said this before, if you want to know more about the super stuff, have a look online, because it's just to do with inheriting from this already made sprite here, not to bang on about too much. So the first things that I'm going to do is this class, the first thing it will want to do, it's going to open the map that we pass it, and it's going to open that in read mode. So this map that we pass it, in a minute when we create a tile map, we're going to open it up in read mode. So this map will be the text file that we pass it to this text file, it's going to open that up in read mode. So like I said before, the reason we're not specifying that specific text file, this one here, map.txt, the reason we've not put map.txt in here is so that when we create the object, we can pass it map.txt, map2, map3, boss level.txt, whatever we want. And then we're going to load in the sprite sheet, and we're going to do that dot load, and it's going to load a sprite sheet. So again, it's exactly the same as before. We're not going to pass it in the specific sprite sheet, this overworld small.png. We're going to just pass it a sprite sheet, and then we're going to tell it in a minute when we make the level which one we want to load, because I've actually got two different versions to kind of demonstrate my point. And that is all we need for the class's attributes. We're then going to make a function for it called loadMap, and what we basically need to do here is we're going to create two lists. So if we look at our map, we basically need to create an array of lists. So we need to create this line as a list, this line as a list. So we're kind of going to make like a 2D array. So it's going to go across and then down. And we need to basically we need to make a 2D array to do that. So we're going to do that now with a nested for loop. If you don't know much about that, I think I've got a video on for loops, on nested for loops. So have a little look at that. So we'll start with an empty list, which is my tile map. I then look at the size of each tile. So these are 24 pixels. I'm not sure I actually use that in this iteration of it, but we'll keep it in anyway because it's good to have it. So for row in range, 0 to 20. So what I'm saying here is that the row, so this row here has 20 positions. Okay, that's all that basically does. I do that with this next line. So I create 20 positions in that row by doing tilemap.append, and I append a new empty space. So that makes my row there, and I need to do that 20 times basically. Okay, so I then do again, so now I come down and do the column. So for column in range, I do 0 to 20 again. I'm going to do tile map, and then the row that I'm on at the moment, and then dot append an empty space to it. So using this, I can basically create an empty. So I'm going to go to whatever row I'm at. So at this beginning bit here, if my row is at 0, I then go to, so it goes tile map and then 0, and then it appends 20 blank position, 20 blank basically kind of positions waiting for strings to be written in there. So that's how those two work together. So if we think about this row here, basically this row here is just basically creating this first position here. So all the kind of like that just that first position there, and then the second one appends 20 empty spaces to it, so it goes all the way across the 20, and then when it's done 20, it kicks back up to this for loop here, and it goes down another row, and then it goes this again, and it does the next 20, so then it appends 20 empty positions to it like that. So I kind of hope that makes sense. A little bit of a whistle stop tour there of nested for loops, but now what we're going to do is because we basically have a blank grid ready to read this into, so we need to read each one of these positions into the correct position in that 2D array we've just made. So we can do that by doing for x in range 0 to 20, because there's 20 positions. We don't need to do this last bit, printing the line, but that will just show us as we're going through how it kind of works. So this file which I've read in is here, which is the map file. We're going to read the first line of it. So basically we're going to read the whole first line of it, and we're going to do this 20 times. So the next time it goes round, it'll read the second line, then the third line, and it'll keep doing that until it gets all the way down to the bottom. So it reads the first line of it, and then it is going to, we're doing for y in range, again 0 to 20, we are going to check that position. So it reads the first line of it, and then well actually I'll write this line out so we can see it actually working. So if line y, wherever I am, is equal to 0. Okay, so let's have a look at this first of all. This line here is having a look at what position we at the position of the tile map here. So if that, so we've read in the line basically, and we're looking at each position 0 to 20 on this line, so 0 all the way to 20 on that line. If any of those positions ever equal 0, we are going to draw on the tile map a position, or give the position on this tile map these coordinates. Okay, so the tile map, the x of it is defined here. So basically this first row here is going to be 0, and then that y, this y here, is also going to be 0. So when I look at this first row here, so this goes through each row one at a time, 1, 2, 3, all the way down, and then y looks across the row at each position. Okay, so if I'm at, so for example this one here, this is actually the top left corner. So this is the top left corner, so this is the first position. So when this first runs, x is equal to 0, and then y is equal to 0 as well. So 0, 0. So the tile map position is 0, 0. Okay, if that position, so if y is equal to 0, which is here, it means that the tile map position 0, 0 is equal to this. Okay, now this is the coordinates on the sprite sheet of the top left corner. So the top left corner, if we look at this here, the top left corner gets drawn, if we know our coordinates, from 0, 0 in this top left corner here, and then this is the width and height of it, so it goes down 24 and across 24. So it's saying here, if the line ever has 0 in it, save these coordinates, which are these ones here. Okay, now what I'm going to do is I'm going to quickly type in the rest of the arguments, because the rest of the arguments are all exactly the same as this, but they just look at all the different numbers on the map. So they look at 1, 2, all different numbers and symbols that I've got on the map, and they just give them a different set of coordinates here. Okay, so we can see now, I've just put a few little comments in here. So for example, the left side here, if y is ever equal to 4, which is on the left hand side of my text file here, then wherever I am on my tile map, the x position and the y position is going to be equal to 0, which is the very left hand side, then 24 down, and then a size of 24 and 24. So if I look at this again, 0 across, 24 down, and then 24 by 24. So this sort of space here. Okay, that's kind of what it's going to be looking at. So I've done that for all of the different symbols that I've got. So you can have a look at mine, you can choose your own, but if you follow that kind of those rules there, you can kind of put in any sprite sheet. The only other rule you have to think about is to make sure that all of the squares on the sprite sheet, so like they're all like the same. So this is 24 by 24, and then that would be 24 by 24. You can't really have a tile on this sprite sheet which is slightly bigger or slightly smaller, because it's not really going to work out. Okay, so all of the little squares need to kind of be the same. If you've got one like this one here, for example, I believe I had that as that one. and then whenever I draw it, I just draw this position next to it, so it kind of comes over 2 squares there. But it would be easier if all of your tiles were 24 by 24, so you had that grid system worked out. And then, okay, so that is our sprite, our sort of tile sheet there. We can just, so that we can see it working, print out the tile map. So print tile map. I think I'm going to need to go back a couple there because I want to print it out at the end. There we go, print, and then tile map. Again, this is just for our sort of debugging purposes. This is only going to print out what the tile map looks like, kind of each kind of run through the loop, and then we're going to return the tile map as well. The last thing that we're going to do for this class is give it a draw function. So we're going to define a draw function, which is going to take the tile map, and it's going to take the window as well. And then all we're going to do is this for loop, so for x in range, and then for y in range, window.blitz, this is drawing to the window, self.tiles, y, so this is just a little bit of maths here, y 24 x, so this is just printing out the positions. And that's it. So it takes, so basically this here is the coordinates of where I want this to be drawn. So for example, I want at 0, 0, this is going to be 0 times 24, and then 0 times 24, so that would make the position 0, 0, and then my tile map will be at position 0, 0, which is going to draw the top left corner, and the first thing that's in my tile map is the top left corner, which is 0, 0. And then as I iterate through this, so as x then goes to 1, this is going to be 0, which will still be at the top of the screen, and then 1, x will go around to 1, and sorry, the other way around, so y will go around to 1, and x will still be at the top of the screen. And it basically creates each one of those positions as we go around. You kind of have a little play around with it as you do. If your tiles are different sizes, then these numbers will need to be the width and height of those tiles. Same for these as well. Not sure if I said that earlier. And that is it for the classes. So this will actually draw now. All we need to do now is actually get like a window up and get that bit running. So let's just define a quick main loop. And I'm just going to very quickly make the window for it. So again, we can see width and height 480, multiples of 24 there. So I'm not going to have any, extras or anything like that. The speed, we don't particularly worry about that at the moment, but this is going to be something that then builds into like an RPG style thing. So good to kind of build it out right now. And again, count will be something we use later on in kind of an RPG style thing. And then we're going to make a window. So just setting a little caption at the top. And then we want to, so now we're going to actually use the classes that we made. So we're going to make a variable called level, and we're going to say, and we're going to set it to tile map which is the, if we look up here, which is this class here, and we're going to pass it in the sprite sheet and the map. Okay, so this is where you can pass in, if you recalled this a number of times, you can pass in different sprite sheets and that sort of thing. So I've got overworld small.png to be passed in, and then my map file as well. And again, same thing for the map. If you wanted to draw a different map, you could literally just change it here and it would draw your new map without you having to mess around with the class or anything like that. The tiles are going to be equal to the level.load map. So level is now an object, and we can use the function we made for that object. So up here we made a load map function. So here when we create the level object, we can do level.loadMap, and it'll do all of this stuff that we just programmed it to do. It'll look through the sprite sheet and the text file, and it'll basically create the grid of coordinates we need and ready for it all to be drawn. And then the last thing that we need to do is we need to do a bit of an update loop here. And this is going to be, so we basically want to keep on drawing our level. So we're going to draw the tiles to the window, and then we are just going, so now this last bit, so that is it now. This would actually draw to the window, but it would also like crash out and things like that. So we're just going to do a little event catch. So for event in Pygame, .event.get, if the user basically quits, so if event.type is equal to quit, we want to Pygame dot quit, and then just exit like that, and that, I believe, is it. We need to update the display, pygame.display.update, and then tick the clock by 60 frames per second. And that is all done for now. So if I now call my main, if there were no errors as I was typing quite quickly, fingers crossed there were no errors, it should, no, oh, so here that should have been self.tiles equals pygame.image.load. There you go, should have been spent a bit more attention there. So I'm loading in the file, and then the tiles get loaded in as well as that sprite sheet. So let's just load that again, see if that's going to work this time. And there we go. My FPS isn't defined there, but we don't need that now, right now anyway. But we can see here that that's drawing that really nicely. Let's just comment that out for a second. Oh, because I called it FPS. So so just to show you how easy it is to load in a different world, so let's just check to make sure that one's working properly now. So there's my world, nice and loaded in, really easy there. If I want to load a different level in, I've got to quit that first of all. If I want to load a different level in, I literally, so this level here, overworld small 2, just change that to a 2 there, run this now, and that loads in my sort of like saturated, you know, palette swapped level there instead. So you could do like a Legend of Zelda kind of thing where you're going into the dark world and the light world, and it's just as easy as that to kind of load in those two sprite sheets and swap between them. And that's really it, guys, really. So I hope you enjoyed that one. Just the last thing there, that map, again, that's you can change that to whatever you want. So you can make your own maps, you can make a number of maps, you could load this if certain things happen. So maybe if so when we get into making a character and things like that, if they reach the end of the screen, we can load in a different map and things like that. There's all sorts of different things we could do with this. So I hope you enjoyed that. All the files are going to be up on the GitHub for you to grab, and leave me a little comment or something if you like what you see, and I'll do some more.